The purpose of these videos is to prepare you for introductory physics and beyond. Whether you're the next Einstein looking to unify gravity with quantum mechanics, an engineering student who needs to pass their courses, or the average Joe who just wants to learn physics, these videos will help you get started. The first topic of discussion will center around the question of what exactly is physics? From there, we'll take a detour and pay a visit to the queen of all sciences to brush up on some foundational math that'll be useful for the first chapter. I should quickly mention that I'll be using Giancoli's Physics, Principles with Applications 7th edition as a reference. The math topics we'll cover include order of operations, adding, subtracting, multiplying, and dividing fractions, exponents, some basic trig, common mathematical formulas that you don't necessarily need to memorize but should be familiar with, and lastly, the concept of proportionality. Feel free to skip these sections. However, I highly encourage those who feel their math is a bit shaky to watch them, as it'll make the first chapter go by smoother, and I'll assume you have an understanding of these topics. Once we've gone over the math portion, we'll be ready to dive into the first chapter. We'll be going over measurement and uncertainty, significant figures, scientific notation, units, standards, and the SI system, converting units, dimensional analysis, and lastly, one of the most important topics that'll stay with you throughout your entire physics or engineering career, the plan. Although Chapter 1 is not necessarily exciting, it is absolutely essential. This is where you'll begin to learn how to communicate with other scientists and engineers. Think of it as learning the lingo. Now let's begin. What is physics? Physics is the study of matter, energy, and the way they interact. It not only predates, but it also serves as the foundation from which other scientific disciplines emerged. Many people, including myself, view physics as the mechanism by which we can establish fundamental truth. However, this is not the only view of physics. There are others who think of physics as simply a tool that helps us understand how we perceive the world. Notice the subtle difference. In both cases, we agree that physics helps us understand how nature works. But whereas one group sees this as reality, others see this as our interpretation of reality. Which viewpoint is correct? Who knows? And in all honesty, doesn't really matter for now. The question is more philosophical than scientific in nature. I just wanted to bring it up because it's something interesting to think about. But I digress. In the most general sense, physics can be broken into two categories: classical physics and modern physics. However, these two do branch out even further. Classical physics encompasses areas such as classical mechanics and electromagnetism. On the other hand, modern physics covers areas such as relativity and quantum mechanics. There are, of course, other specialties, but don't give too much thought to these yet. You're a newbie. Your focus will be on studying classical mechanics, or even more specifically, Newtonian mechanics. You'll learn later, if you do decide to study upper division physics in college, that there are other frameworks for classical mechanics, such as Lagrangian and Hamiltonian mechanics. But I say again, you'll be learning about Newtonian mechanics, which can be defined as the study of how objects of different mass move due to the application of force. In other words, you'll be learning about how and why things move. But now that we've discussed what physics is, let's go revisit some math. Let us begin with a brief discussion on order of operations. As the name suggests, order of operations refers to the order in which mathematical expressions are solved. Now, you may be asking, what are these operations you speak of, and why must we follow a certain order? To these questions, I answer. Operations refers to addition, subtraction, multiplication, and division. Now, as to why we need an order, that's because we want consistency. If we give everyone the same mathematical problem, we want everyone to obtain the same answer. Let me give you an example. Consider the following problem. 2 plus 5 times 3. If you are unfamiliar with order of operations, you may say, well, 2 plus 5 is equal to 7, and 7 times 3 is equal to 21. Therefore, the answer is 21. But that would be incorrect. The reason why that's incorrect is because it goes against the world's agreed upon way of doing arithmetic. The answer is 17. Multiplication is done first, then it's the addition. 5 times 3 is 15, and 15 plus 2 is 17. The order of operations are as follows. If anything is enclosed by parentheses, you do that first. The next priority are numbers with exponents. After that, you have multiplication and division. Now, one thing to note here is that when it comes to multiplication and division, one isn't prioritized over the other. That's why I've grouped them together. If you begin dealing with a problem that has multiplication and division, the convention is to solve the problem from left to right. Let me give you another example. Consider the problem 3 times 6 divided by 2 times 2. In this problem, we see that we're dealing with an expression that involves both multiplication and division. I'll restate that the convention is to solve the expression from left to right, just like how you would read a sentence. So here you start off by multiplying the 3 times 6, which gives you 18. Then you divide 18 by 2, which gives you 9. And lastly, you multiply by 2, which brings you back up again to 18. And this is your answer. Addition and subtraction follow the same rules as multiplication and division. Addition is not prioritized over subtraction, nor is subtraction prioritized over addition. When you're dealing with an expression that contains these two operations, you simply solve it left to right. Having gotten that out of the way, I must clearly state that multiplication and division does come before addition and subtraction. This may be all a bit confusing, but luckily, there is a well-known acronym that can help you remember the order of operations. Let's take another look at the original list. If we take the first letter of each word, we get the word PEMDAS. One way most people remember this is with the sentence, "Please excuse my dear Aunt Sally." Now let's do a quick recap. Whenever you have an expression, first check and see if there are parentheses. If there are, it does not matter what operation is enclosed within the parentheses. Be it multiplication, addition, or subtraction, you do that first. Next, check for numbers with exponents. If there are, then you must evaluate them next. After that, check to see if there's multiplication or division. If you have both, solve from left to right. The last operations you do are addition and subtraction. Again, if you have both, evaluate from left to right. Let's go ahead and do 5 examples. Our first example is 8 plus 6 times 2. Multiplication comes first, knowing that we can bring down the 8 because our first order of business is multiplying the 6 times 2, which is 12. We bring down the 12, and now we have to evaluate 8 plus 12, which is simply equal to 20, and this is our answer. The second problem is 20 divided by 5 times 3. Notice that the operations in this problem only include multiplication and division. Therefore, we evaluate left to right. 20 divided by 5 is equal to 4, and we bring down the times 3. 4 times 3 is equal to 12, and that is our answer. The third problem is 12 minus 4 times 2 plus 6. This problem has 3 distinct operations: addition, subtraction, and multiplication. PEMDAS tells us to do multiplication first. 4 times 2 is equal to 8. We bring down the 12, minus 8, and the plus 6. Now we're dealing with addition and subtraction. We solve this from left to right. 12 minus 8 is equal to 4, and 4 plus 6 is equal to 10. And that's our answer. The fourth problem is 10 plus 2 in parentheses times 3 to the power of 2 divided by 6. Now the problems are starting to look a bit more difficult. But do not fret, for PEMDAS will have us set. According to PEMDAS, we solve for whatever is in the parentheses first. Okay, 10 plus 2 is equal to 12. We bring down the 12, then the times 3 to the power of 2, and finally, the division operator along with the 6. From here, we proceed to evaluate the number with the exponent. 3 squared is 9, thus this becomes 12 times 9 divided by 6. Now that we're only left with the multiplication and division, we solve from left to right. 12 times 9 is equal to 108, and 108 divided by 6 is simply 18. And this is our answer. The last practice problem is 24 divided by 3 times 2 plus 4 in parentheses minus 5 to the power of 2 plus 8. Parentheses are prioritized. Our 2 plus 4 is 6. We bring down the 24 divided by 3 times 6 minus 5 squared plus 8. Next, we evaluate the exponent. 5 to the power of 2 is 25. We bring down the 24 divided by 3 times 6 minus 25 plus 8. Although the problem has been simplified, it still contains all 4 operations we've been discussing. Multiplication and division comes first. 24 divided by 3 is equal to 8. So we bring down 8 times 6 minus 25 and the plus 8. 8 times 6 is equal to 48. 48 minus 25 is equal to 23. And 23 plus 8 is equal to 31. And this is our final answer. Anyway, that is it for this lecture video. I leave the following practice problems for you to solve. I'll post the answers at the start of the next video. If you found the content helpful, I'd really appreciate if you'd like and subscribe, as these videos do take a while to make, and please share this video with someone who would find this useful. I'll see you on the next one.